So in this video we're going to show an example of an improper integral that converges to a specific value. So the integral that we're going to work on is the integral from 1 to infinity of 1 over x squared dx. So from 1 to infinity, here's the function 1 over x squared. And what we want to remember is that when we do when we integrate over, if it were a definite integral, what we're finding is, and the same with an improper integral, what we're finding is the area under the curve, or between the curve and the x-axis. And really what we need is the function 1 over x squared to approach the x-axis quickly enough so that this area approaches 0, so we're able to add it up. Whether these integrals evaluate to a number or not is generally going to depend on how quickly the function approaches the x-axis, which is its horizontal asymptote. So the way that we'll deal with this is we'll take the integral from 1 to infinity of 1 over x squared dx equals, and now we're going to take a limit because we can't plug infinity in for x anywhere because infinity isn't a number. It can't be plugged in to x. We're going to instead take the limit as a goes to infinity of the integral from 1 to a of 1 over x squared dx. So once we've implemented our limit notation and replaced that upper bound of integration with the a, we're going to rewrite the limit notation. So we're going to take the limit as a goes to infinity of, and now we integrate this. So when we integrate this, we'll wind up with a negative 1 over x from 1 to a, and we can factor that negative 1 out because it's a constant, so we get the opposite of 1 over x from 1 to a. Notice I don't have an infinity up here. I can't put infinity there. I'm taking the limit as a goes to infinity. And now we'll go ahead and replace our limits of integration in. So I'll rewrite my limit notation. We're going to find the limit as a approaches infinity of the opposite of 1 over a, putting the upper bound of integration in, minus, put the lower bound of integration in, 1 over 1 is just 1. And now we try to take the limit. So the limit of 1 over a as a goes to infinity is going to be 0. So I'm going to bring my negative down, parentheses. This will be 0 because I have a constant numerator and a denominator that's becoming infinitely large, and 1 over something that approaches infinity is going to be 0 in the limit, minus 1. And 0 minus 1 is negative 1, times negative 1 is just positive 1. So this is an integral that converged to a specific value 1. So the area under the curve on the interval from 1 to infinity, this area adds up to 1. So here's this. So the most common error that I see is in this step right here, where I see students put, instead of putting the 0 in because they take the limit as a goes to infinity, I'll see students replace the a with infinity. But we can't do that. Infinity isn't a number. We can't plug it in for something that's playing the role of the variable. So this will always be a deduction in an exam setting every time that it's done. So it isn't 1 over infinity. Infinity isn't a number, but the limit as a goes to infinity of 1 over a is 0.